battery, the word brings up a number of different chemistries, sizes, and capabilities. When considering what battery technology to use, there are a few important attributes to keep in mind. Namely, first off is milliamp hours. You'll see this rating printed on most batteries. It tells us how many milliamps the battery can supply for a period of 1 hour. So, this lithium polymer battery can provide 1200 milliamps continuously for 1 hour. Milliamp hours tells us how long a battery will last. Nominal cell voltage. This is how many volts one cell of that battery chemistry can generate. No matter what size the cell is, it will always generate the same voltage, as long as it uses the same chemistry. Rechargeability. Can the cell be recharged? If so, how many times can it be recharged? So now that we have those basics down, let's look at the most essential battery types, starting with alkaline batteries are a household name, and for good reason. They're inexpensive and long-lasting. They're also available in a variety of sizes, with capacity that increases according to size, such as AAA, AA, C, D, and PP3, more commonly known as a 9-volt. All of these other sizes provide alkaline's nominal 1.5 cell voltage, but the PP3 provides 9 volts. And how does it do that? Simple. It's not actually a single alkaline cell. Inside every 9-volt alkaline battery is actually 6 small cells providing alkaline's usual 1.5 volts each. This trick is possible because cells wired in series provide a cumulative voltage. 1.5 volts times 6 equals 9. Because the terminals on a 9-volt are so close together, you can actually test it with your tongue. Yeah, don't do that. It's stupid. Coin and button cells are well suited to applications where space is at a premium and current consumption is low. But the term coin and button really only describes a general form factor. These little guys can be made using alkaline, zinc air, lithium, as well as other chemistries too. So their characteristics can vary quite a bit. Some are even rechargeable. The most common coin cell size is likely the LR44 alkaline, as seen in watches, hearing aids, and many other ultra-compact devices. Like their big sisters, these are 1.5 volt cells, but the capacity is 1/10 of a AA battery. Another common size is the CR2032, a 3-volt lithium cell. These are wider and flatter than an LR44. Being a 3-volt cell means they can even be used for things like this. Classic. Common coin and button cells are pretty inexpensive, as long as you don't buy them at a drugstore. For some reason they cost like 5 to 10 times more there. Alkalines are all well and good, but once they die, they're headed straight to the landfill. A greener alternative is nickel metal hydride. These are relatively inexpensive rechargeable cells, and they're often used as drop-in replacements for alkalines. But it's important to keep in mind that they only supply 1.2 volts per cell compared to alkaline's 1.5 volts. This means that your flashlight might just be a little dimmer. And for the record, modern nickel metal hydride batteries do not exhibit the memory effect, which means they don't need to be fully depleted before they're recharged. So you can top them off whenever you feel like it. Nickel metal hydrides have about the same capacity as alkaline batteries, and they're even a bit better at powering current-hungry devices. But it's important to keep in mind that they do self-discharge at a faster rate. So, generally speaking, keep alkalines in your smoke detector and nickel metal hydrides in your game controllers, or your milk frother. You have a milk frother, right? Lead-acid batteries are the oldest rechargeable, and with their low energy density, they're also the heaviest. They're still in use today because they're so good at providing very high surge currents, as in tens of amperes, which makes them really good for applications such as starting a car. Lead-acid size and weight means you won't find it in personal electronics, but if you have a power-hungry project that needs to run for days, lead-acid is your best choice. I hear robots are quite fond of them. In stark contrast to lead-acid, lithium-ion and lithium polymer batteries deliver a lot more energy for their weight, but they're significantly less durable and far more expensive. You'll find lithium-ion cells usually come in a rigid casing, whereas lithium polymer cells use a soft pouch, which is lighter and more compact. This streamlined design is great for keeping portable electronics small, but it also makes the cell susceptible to punctures, which can quickly lead to shorts between the electrodes, overheating, off-gassing, and subsequent undesirable explosions. That being said, lithium cells are the most popular rechargeables nowadays, available in an impressive array of sizes, from tiny 2 grams all the way up to the monsters used in electric cars. And that's the basics. A variety of battery types for a variety of uses. It's important to choose the right cell for the job. Now, if you excuse me, I'm going to go recharge myself.